Statistics Modeling of Finance, Chapter 2, Measures of Central Tendency, page 8, Mean of Grouped Data.
Mean of grouped data. The arithmetic mean is a simple, but powerful, tool. It is the mathematical average of the numbers. It gives you a handle on a batch of numbers. It is something everyone is familiar with, and it is pretty self-explanatory. People are used to dealing with averages. The average temperature for the day was 64 degrees, or the average age of a player in the NBA is 24.8 years. Appraisers may utilize measures such as average number of days on the market or average rent per square foot. The mean is a prime measure of central tendency. Things tend to cluster around an average. The average is part of a population of the numbers, and is somewhere around the middle, between the high and low extremes. It is the first impulse when you face an array of numbers. Gee, I wonder what those numbers mean? Let's find the average. There are few limitations. You can always take an average. However, the mean may not be one of the actual numbers in the distribution. In our last exercise, the mean was 38.8. None of the 11 numbers was 38.8. The closest was 33. The mean can be affected by extreme variance, by excessively large numbers that are significantly larger or smaller than the rest. Here are 8 numbers. 1, 2, 3, 4, 5, 6, 7, 1 million. The mean of these numbers is 125,003.50. That is not a meaningful number to describe the data set. 7 of the 8 numbers are between 1 and 7. You would be best off to throw out the 1 million figure as atypical or an outlier. But if you had no choice, and had to use all 8 numbers, you would be better off using another measure of central tendency, such as the median, which we will discuss shortly. All the means we've calculated to this point were of ungrouped data. We just listed out all the variates, and aggregated them before dividing by n. That's the normal way to proceed, and works well when you have a variety of numbers. Example, in real estate, many times we encounter situations where we deal with repetitive numbers, or grouped data. Suppose we are analyzing rents of comparable apartments. We find there are 17 renting for $950, 14 renting for $975, 20 renting for $1,000, and 8 renting for $1,050. To find the mean, we could enter all 59 numbers individually into our calculator, then divide the aggregate by 59. That is tedious, and there is a better way. The formula for finding the mean of grouped data is F equal frequency, the number of times the variate appears. Fx is the product of the frequency and the variate. For example, it might be 4 times $900 monthly rent, or $3,600. Sigma fx or SFX equals the sum of the frequency times the amount of the variates. First, let's construct a table using the data from the apartment example above. We enter data into the F and X columns, and then calculate their product to enter into the third column on the right. Then we can take that data and enter it into our formula. SFX $58,200, X equals $986.44. N 59. That sure saves us a lot of time. End of page.